Texture repetition or texture tiling is a pretty common thing that you come across when you are building your landscape in Unreal Engine. Hello and welcome to this video. Today we are going to take a look at all those methods which we can use to create a material which does not repeat itself and we get some natural looking textures. We'll start with this basic textures and work our way up to this material which has this natural color variation. Create this, let's create a material and rename it as LM_test. LM stands for landscape material. So when you create your material, it looks like this. It's not different from any other material that you create. So you don't have to do any additional thing to create a material for our landscape. So let's start with bringing our textures in. So we'll take a texture sample and put our grass textures in it. All of the textures that I'll be using in this videos from the Megascans, which is inbuilt in Unreal Engine 5. This is the grass texture that we'll be using for this. So we'll go to the Megascan folder and in surface we'll look for the mossy grass. And this is the grass textures that we'll be using for this. So with the new Megascans in Unreal 5 you will get 3 textures. The first is diffuse texture, normal texture and ORD. So we'll bring them in our material. So the first goes in the base color, then normal, and this ORD stands for occlusion, roughness and displacement. So the red color channel is our ambient occlusion, the green is our roughness and the blue is displacement, which we do not need for this one. So we'll leave it at that. And by simply connecting them to our material and changing our landscape material to the one that we created just now, we get this. So we get this pretty shiny material. This is from our specular light. So we'll put the specular to 0 for now. And as you can see, you get grid type structures. The texture is repeating a lot. We will use landscape coordinate. So this is used for UV textures. We apply this directly to all of our texture samples. And if we divide it by any scalar value, let's call it tiling, and put 3 by default. And now we can control our landscape coordinate with that scalar value. Now if we increase it to 10, you can see that the textures are bigger than before, and if we increase it further, then they will keep increasing their size. So ideally what you would want is anything which is closer to where you are looking to be smaller, and anything that is far away that can be bigger. To have good UVs, you would need to know the overall resolution of our landscape. So when you are creating your landscape, there is a section called overall resolution, and here you can see it is 4033 by 4033. We will remember this value and put it in the mapping scale of our landscape coordinate, which will apply the texture on our whole terrain without any tiling. So if we take a look at what the landscape looks like, this is our landscape, and the texture that we applied is applied on this exactly one time. So if we imagine this as the default scale, so with tiling 1 is the smallest value of our textures, and if we increase it, we'll get more and more texture repeating. The higher I go, the more the texture will be repeating. We would right click and click play from here, so our mannequin is right here. So you can see how much our texture is scaled with respect to our mannequin. And now we can adjust the tiling value so that we can see which scale looks realistic. Now coming to our first method to reduce the texture repetition, we would do a distance blend. So what distance blend would mean is that the textures that are close to us would be smaller and the textures that are far away would be larger. So we will take our diffuse textures, duplicate it. So for the near tiling, we will multiply our UV 1000 by default. We would duplicate it and that would be our far tiling, and then we multiply that by our UVs and put it in the second texture sample that we duplicated. So the first one is the tiling scale for the textures that are close to us, and the second one is a larger texture for far away points. This is the inbuilt material function and it needs some outputs. First one is the fade length, so we would create a scalar and call it fade length and plug it in. Then we would set the default value as 2000 and then we would duplicate this and set the fade offset. So now this camera depth fade will give us the values that we need to blend. So we would put a linear interpolate. So we would put A the near tiling textures, and in B we would put the far tiling, and as the alpha we would put the camera depth and putting in the base. With linear interpolate, depending on the value of alpha we get A and B value. So if the alpha is 0 somewhere, then we would get the A value, and if the alpha is 1, then we would get B. Now let's change the far tiling so we can see it clearly. So by default we put fade length and fade offset as 2000. So it means that after the 2000 distance there is another 2000 in which our first tiling and second tiling are blending. So you can see it clearly right here. Our textures are blending depending on the tiling. We can change the tiling value and see how it affects. So you can see most of our tiling is gone. We can still see some of the tiling close to us. You can see here this texture is repeating again and again. So this is all about distance blending. Since we will be using this landscape coordinate for all of our UVs, let's put it in a comment box and name it UV so that it's easier to spot. Similarly, we'll put the distance blend right here. Again, let's change the color. Now we'll be using this UV and distance blend for all of our results. Now to keep our material clean and not have all those webs where we don't know which pipe is going where and it's all a big mess, we would use material function. So to create a new material function, we would right click, go to material and textures and click material function, and we would name it mf_test distance blend. So we will use this material function to blend it based on the distance. And with the material function we can have as many number of inputs as we want, and similar for the outputs. So if you right click and type function input, we get an input, and if you type function output, we get an output. Now let's rename it, call it height, and let's change the input UV. Now we can duplicate the input and call it input texture. Now we have 2 input and 2 output. So to use our material function in our landscape material, we would just drag and drop it in our material. Now we have the input and output that we named in that material function. Now if you notice, for the outputs we have high first and the result is the second. We can change the order of any input or output. For that we would change the sort priority. So the less the number we put here, the first priority it is given. So if we type 2 here, then the height should show after the result. Now this is our custom created material function. We also have some inbuilt engine created material functions such as this camera depth fade. It's getting the distance between camera position and the absolute world position, and it's doing a bunch of calculations, but we'll be using our own simple distance blending, which is not that complex and only uses camera position and the world position. Now let's create our distance blend, which is blending our two textures with a linear interpolate. So basically it means that we'll be replacing all this with our distance blend material function. So for that, let's take a texture sample. So sometimes when you are creating your landscape material, there will be times when you are getting some artifacts like some of your textures are not showing up. There are some spots where your default material will show. So to fix that, you would change your sample source from texture asset to shared warp. Now we'll duplicate this texture sample and use that for our UVs. So we'll take the UV input and then multiply it twice and multiply one with the near tiling and the another with the far tiling. Let me change the default values. For near tiling we'll choose 1000 and for far tiling let's say 100. Now put that in our UVs and now let's interpolate them with a LUT. So we'll put the near tiling in A and the far tiling in B, and for the alpha we'll use the distance blending value. For that, let's make an input. We'll take this texture input and rename it. By default it is a vector 3 input type. So for alpha we only need a scalar values goes from 0 to 1, so we'll change it to scalar and put this as in the alpha. So whatever we put in our distance blend output, that will be connected directly to the alpha. And now let's connect this to our result. We don't need this output height. This was just to show you that we can get multiple outputs, and we get an error. So this one tells us that we are missing input textures. That is because the texture samples are empty. We are not using any texture. So we will give our texture input. So we'll use another function input to input in our texture and change the input type to texture 2D and call it in texture. And now let's connect that as the texture. And now we get another error which is saying it's missing a preview connection. It needs something for our texture to calculate things. So we'll put a default texture object and connect it. So now that error is gone, and we get another error which is saying that correlation failed trying to convert float 3 to float 2. And that is because we did not change the UV input type. We have put it as vector 3, but for UV coordinates we only need 2 xy, so we'll change it to vector 2. And now the error is gone. And just to make sure that we get only 2 outputs, we'll take a component mask and choose the red and green channel. So it's only taking the X and Y from our UVs. This is not necessary to do since we change it from vector 3 to vector 2. And if we take a look at the distance blend, we get all those inputs. Let's take our tiling and make it the input. So we will put a function input and call it near tiling, and change the input type to scalar, and then duplicate it and call it far tiling. And then let's put it as multiply, and for the preview values we'll put the scalar values that we created before. And if you choose any input and click use preview value as default, this one right here, then it will use whatever preview value that you are supplying as the default value. So if nothing is connected to it, then it will take the preview value, and if we connect any values in our material function, then it will overwrite that value. Connect it to our base color. So it's saying we are missing those inputs. So if we put distance blend and UVs, all of these textures were not using any default value, and we had to supply any values, otherwise they would be empty. So that's why we were getting the error. And your texture, so we'll take a texture object for that and put it in, then the error went away. For the tiling, if we undo it, we'll see that we get error saying that these two needs input. But if we are using the preview value as the default value, we don't necessarily need to supply those values. We'll be using those values as the default and the error should go away. So this one is especially useful because most of our textures we are using Megascans and their textures are 2 meter by 2 meter, or you can just say that they are the same scale, so the same tiling will work for all of them. So that is the far tiling, near tiling which we are using in the material function. That will change for all of the materials that we are using in our landscape. But if you want finer control over any texture, you can put a scalar value and connect it to that material functions. It will override that value and that scalar will control the value for only that texture. Now you can see inputs and we want to sort them out so that our UV is at the top and the distance blend is at the bottom. So we'll take UV and this is priority 0, which means it is given higher priority. And now we'll change our texture to the priority after that, so let's say 3. So we'll use a higher number for all of the other inputs. So for texture we are using 3, and for near tiling, far tiling and distance blend you can also use 1, 2, 3, 4. But then if you have to make another input which you want, let's say right after the texture, so you will put priority 2 in that, but that value is already used by near tiling, so you'll change the tiling for near tiling as 3, then far tiling 4, 5. But if you have already given a gap in between, then you can just put that as 4 and the near tiling is already a higher number. It's just easier to make changes like this. So we'll put 6, 9 and 12. Now if you save, you can see that our inputs are sorted according to that values. Now we don't need these. We'll delete one and change this, right click and convert to texture object. So this is the texture that we'll be using, so we'll just connect it to the material function that we just created. Now this is for our base color. And now another one of the reason why we should prefer material function, because now we can duplicate and use it for our normal. So you can just connect it directly into the normal and should make all of the connections. So let's create a texture object and put UV, distance blend, our texture, and we are good to go. Now we can use the same material function as many times as we want and make our graph cleaner and easier to navigate. We'll do the same with the ORD texture. And the only thing that we need to change here is put a component mask. Remember in ORD we had occlusion, roughness and displacement. So occlusion is in red, so for our first component mask we'll tick only the red channel. Roughness was in green, so for the second we'll choose green and connect the first one to occlusion and second to roughness. So this is our texture distance blending. We'll use our own distance blend which is far less complex. So in camera depth field, if you see, it's using camera position and the word position. So we'll just copy these two and paste them here. Let me just make this bigger. You can get the same from searching like word position and camera position. Now let's get the distance between them. So if we search distance and scroll a little under utility, we'll find this distance. So this distance can get the distance between any 2 point, color or positions. So distance we are getting the distance between word position and camera position. It's time for some math. So imagine we are here. So this is where our camera is and we are looking at this point on our landscape. So the first thing we did was get the distance between the absolute position and the camera position, which is this, and now we subtract any value from it. That would be our offset. So if we subtract this value, we only get this distance. So this is the fade offset that we were getting from the camera depth fade. And for the rest of the stuff which is left here, if we divide it by any values, so let's say this distance is 100. If we divide 100 by 100, we get 1, which means the whole fraction of this length. If we multiply it by, let's say, 0.4, we get the 40% of this length. So whatever we divide it by would be the distance at which our textures are blending, or you could say the fade length. So if we come back to Unreal, and from this distance we subtract, that would be our fade offset, and then we divide, that would be our fade length. Now let's delete those connections from there. And now let's put saturate. So what saturate would do is it will clamp the values between 0 and 1, and it does not take any processing time. And then we would do a 1 minus x. If you remember the graph from before, all of the values that were subtracted and divided, that was away from our camera. So if we subtract it from 1 minus x, then we'll get the same distance but close to the camera. Now just to make sure that it is a scalar value, we'll take a component mask and use the red as the channel. So this is our distance blend. This we are doing because the word position and camera position, those are vector values, and with mask we are getting only a scalar value. Now let's redo the connections and then organize it. Since we were using 1 minus x, we have to change some of the connections in our distance blend. So we would go to our material function that we created before and just change the input A and B. So now A is the far tiling and B is the near tiling. Now let's save it and come back. Now we are getting the same distance blend but with a far less complex distance blend. And make sure that all of the connections are the same and take a look at our landscape. And now to get even less tiling, we would take another grass texture and blend that with the original one that we have. With the use of material function, it is very easy. You just have to duplicate all of that and make the connection for the UV and distance blend. And to blend them, we would need material attribute like base color and all of them. So we would right click and click make material attributes and make those connections of base color, normal and roughness. Let's not do that for the ambient occlusion since we only need to see our tiling. And connect the UVs and distance blend. Now let's take a look at the other textures that we are going to use. So if you go to your Megascan folder, so this is the texture that we are blending, and let's take a look at our original, and they are already quite similar from the start. So we take all those three graphs. By default it converts them to texture sample, so we'll convert them to texture object, or we can directly right click texture object and then put your texture right here. And let's delete the one that we were using before and remake those connections. And now we have two different materials, and now to blend these two we are going to use matte layer blend, simple. This one is also another inbuilt material function, so it's just easier because it takes the material attribute as the input. So we are using this, and we'll put our grass A in base color and grass B as the top color. So this is the same as the A and B input from our LUR, and this is the alpha that is used from the LUR. It's doing nothing more than taking, like, say, base color from A, base color from B, and using a LURP with the alpha that we provide, and then we will create the alpha for our material blend. First, let's connect it to our material. So first we will append a break material attribute node here, and then we can disconnect those connections and connect them with the material here, the base color, roughness, and then the normal. Now let's come back to the alpha. For the alpha, let's use a texture. So this is a inbuilt Perlin which is in the starter content. Since this is alpha, it will need a scalar value, so we'll use the red channel as the alpha and connect the UVs and save it. So by default, if you remember that the landscape coordinate will put this Perlin as a single texture on all of our terrain. Now if we take a look at this, and these two materials are blending, it's actually really hard to tell. So if you see in the Perlin right here, the difference between the white and the dark is not much. So we'll add a contrast and use a scalar parameter. Let's call it matte blend contrast. Let's change the default value to 0.1. So here in the dark areas, this is the second texture that we are using, and here is the first texture. Really hard to tell the difference between two since these two were similar. Now this is a simple Perlin, but you can also use a splat map here so that you have more options. So if you were using the splat map, you would use a component mask, and we are using only the red channel here. And let's change the texture to a splat map. This one has the red, green and blue channel. So the advantage of using a splat map over a normal Perlin would be that if you want, let's say, a dense mix, then you would use the red channel. If you want a sparse mix, then you would use the blue channel. So that's why we are using a component mask here, and we can right click and convert it to parameters. So in the material instance, we can easily change the parameter value and put the contrast after that. Now you can clearly see the difference. The one that is light in color, this is our texture A, and the one that is dark is our texture B. So you can do all those brightness, contrast and saturation adjustment right after here for both of them so that they blend better. But we are only going for the tiling, so let's keep it simple for this tutorial. And now let's create another material function for the alpha. Name it AMF underscore matte blend alpha. Now we open this and copy these from here and put them here. Now let's make input for our UV vectors and change the input type to vector 2 and put it in the UV. And since this is a splat map which is created in an external application, but you would have, let's say, a Perlin to combine those, so you may want to have some tiling for your Perlin. So for that you would just multiply that by a scalar value called tiling, but we are not going to do for this one. And now let's make another input for our blend contrast and make it scalar and connect it there and use that as a preview value. By default it will use 0.1. And let's make another input for the material texture. We'll duplicate the UV now let's change the sort priority. So we'll want a UV at the top. Browse to where this material function is, take it and drag drop in our landscape material. It is giving error because it needs the UV and the texture. Let's bring a texture object here and connect it to texture, and let's search for that variation splat map that we have. Now if you were to change the contrast from 0.1 to, let's say, 1, you can see the contrast of our texture changing here. So let's just leave it at 1 for now. So you can see that there is no tiling in close to us, then there is no tiling far to us, but there is a little bit of tiling in the middle distances. So we would solve that with the texture variations. So we would want to add texture variation after all of this is done, so that it is applied the same for both of the textures. So if you go to starter context, materials, and the grass, this is the startup material, and you see that there is a micro variation texture here. We would simply just copy it from there and paste it here. So now we will take a linear interpolate and put this as alpha. So material attribute does not work with LURP. That's why we were using matte layer simple before to blend our materials. So for that, from here we would connect a get material attribute and click plus and choose base color here, and we can use the base color as the B output, and for the A we would multiply that base color. Now we are using a vector 3, so if you press 3 on your keyboard and left click, then it will put a vector 3 for you. You can right click and convert it as a parameter so that you can easily change in your material instance. And now let's rename it as micro variation color. Let's choose a value of, let's say, 0.5 and just multiply it by that, so it will darken in those areas that were created by the micro textures. And now let's connect it again. You cannot do that with your base. Another set material. So you take all of the material attributes from before and then choose the base color, so it will only overwrite the base color. So if you connect it, click save, and as you can see here, you get all of the small texture variations. And now we do not have any tiling anywhere, and it's looking pretty good. So if we click play from here, let's move around a bit, and the tiling is solved. Now you can also change the color from here. So let's say you give it a dead grass color, so all of those would be converted to a colored input. You can amplify this further, but that will just look unnatural and we don't want those colors. So now let's name it as micro texture. And now you can see that in the starting grass that we're using these texture coordinate, but we don't want that, so we'll just delete it and use our own UVs. So we take word position and then connect it to our UVs. So before that, let's create a divide, and for the divide value we would use a scalar value. So let's call it micro variation tiling and give it a default value. So before that, let's solve our error, which is saying float 3 is converting to float 2. We got the same error earlier, and it's because absolute word position gives us a vector, but for UVs we only need two values, X and Y. So we'll take a component mask and only use red green for that. And now let's change the default value for this as 9000. Now we did our own UVs because we want to change the tiling for our micro variation. Here if we change it 100, we get even smaller micro variation. So you can control the size of the micro variation from right here. Now you can see that we get micro variation close to us. We are also getting some of them in the far distances, which is looking really ugly. So we would do a distance blending for them. So we come here and take another LURP, distance blending as the alpha. And remember, since we were using 1 minus x for our distance blending, so we would put far tiling in A and near tiling in B, so we'll connect it as B. And for A, we would connect the base color which was coming from before and use that as a base color. And now if you look at that, we only get those micro variation close to the camera. And so if you go far, no micro variation, and then boom, micro variation. Maybe now let's make a comment box here Let's call it matte blend. Move this out of way. Now will come the most amazing part, which is the macro variation, which will take our material and give it realistic color variations which we see in nature. For that we will take a texture sample. Let's connect the UVs, and for this texture we would use this grass texture. This is again created in Gaia, so it's based on the natural flow deposit, all of that. So for the Gaia users, it's basically just the output from the texture node. And then just like this flat map where we used the RGB channels, we would take a component mask and then take the red channel for now, and let's convert it to a parameter. So if you want to change the texture from there, you can easily change the mask. So you name it macro variation component mask. Let's call a blend overlay. The blend overlay just simply blends it as a overlay. So we put base color as our base and the macro variation as our blend. Now if you take a look at this, let me zoom out. So this is the texture which will be applying our macro variation. It's not complete because it's only giving us the black and white values for now. This is just to show what it's doing. So right here, these are the micro variations. Let's turn them off for now. So use base color as the base. So now you can see you have these areas where it's really dark, and in the same texture you get some of the areas which are brighter, and then in the cavities there are again dark, and then there are also some variations depending on flow and such. So if you see the before and after, this is without the macro variations, and if we connect the blended one, so this is the macro variation. Now let's change the color for the variation. With this texture, if you preview this, so now since we are only using a channel from it, it is only black and white values for now. Now let's delete the UV so we can easily see it on this sphere right here. As you can see here, and we can put a color here with another texture sample. So this is the color gradient which we'll be using for our grass, and for the Gaia users, this is the set map that we get. Now if we put that texture here and start previewing this node, now you can see that this is giving it the colors based on the set map. So now as you can see that those black white values from before are now colored with the texture that we are using now. So now let's use the RGB as the blend and take a look at how our landscape is looking. And this is not the result what I wanted, and something is wrong. We forgot to plug in the UVs. So after plugging in the UVs, and look at that. So we have this amazing color variation based on the flows in the cavities, and it looks much more natural than before. And these light and dark values, those were from the color difference from our actual textures. It's bothering me, so let's make some adjustment to our texture. So I'll put a desaturation here. Actually, let's just multiply it because we only want to darken it. So we'll put a scalar value here. Let's name it darken A and just save it. And now let's see. Yeah, much better than before. Now let's adjust the values so both of the brightness are much closer. So with 0.6, that took care of it all. Now you can see amazing natural textures, and there is no texture repeating anywhere. For Gaia, this is just a set map. Now for the non-Gaia users, this is only a color gradient, so you can make your own. So if you take a look at this color curve, this is something I created and it has some color variation. So to get this, you right click, go in miscellaneous, and there is the curve and the curve atlas. So this is the curve and this is the curve atlas. Color curve has all of our colors, and the atlas can hold as many color curves as you want. So if you go to the gradient curves and press plus, you'll see all of your curves listed here. So let's say here we are using these two. So if you come to our landscape and click curve atlas parameter, there you have it. So first you'll have to choose the atlas here, and after the atlas you can choose the curves that are in that atlas. So for us it is the linear color curve, and then you'll have to multiply it with the texture that was created before and put that value in the blend. And if you save it and take a look at it, so this is the result we get. Not exactly natural, but you can get some pretty results after adjusting the color values in your curve. I'll delete that for now. Or you can use any color gradient created in any external software such as Photoshop. So let's save it. And here is our natural variations. The texture that I was using were not made for this landscape, but they are still looking pretty good. And now let's take a look at the landscape that they were made for. So here is the landscape that they were made for, and as you can see that in the flow values there is some discoloration and the color cavities, and it's matching the exact natural formations that happen, and we get our amazing material. And hope this cleared things up about the texture repetition. I'll put some of those variation textures down in the descriptions so that you could use them in your projects. Thank you for watching, and I'll see you in the next video.